So let's finish up chapter 6 and finish this story on the scientists and how we figured out that spiral nebula are not spiral nebula, they are galaxies. So I'm going to have to ask you to trust me on the cosmological principle. The universe looks about the same no matter where you are within it. We will explain this and understand how this happened when we talk about the Big Bang. But we're not there yet, so I just have to ask you to trust me. The universe has no center, no edges. It's roughly the same throughout. So, Percival Lowell was obsessed with the idea that there was a civilization on Mars. He founded the Lowell Observatory in Flagstaff and was observing what he thought were canals on Mars. We now know that all of that is wrong, but he still started this observatory and began the effort that eventually led to the discovery of Pluto 14 years after his death, but several other really interesting things happened. So Milton Humason was Hubble's collaborator. Everybody talks about Hubble. Very few people ever talk about Humason, but he participated in this task of observing, measuring, classifying hundreds of thousands of galaxies. So when we talk about galaxies, we have to remind ourselves about redshift. When something is moving away from you, the light from it gets stretched as it moves through space to you, and so the wavelengths are redder than they should be, and we call that redshift. When we look in at this image of deep space, the galaxies that are the very farthest away from us, we are seeing them now as they were billions of years ago. Very, very old red light from very young galaxies. So it's really cool. This is one of the reasons that astronomy can be thought of as studying time travel. So for redshift, we put the ants on this ruler. The ruler is made of elastic. We stretch the elastic. The ants don't stretch. But as we stretch that, the stretching is a uniform. So an ant that is, 2 centimeters away seems to be moving at 2 centimeters per minute. But the ant that is 5 centimeters away is moving at 5 centimeters per minute, and the ant that is 10 centimeters per way is moving at 10 centimeters per minute. So the farther the ant is away from you, the faster it appears to be moving. So this relates back. So Lowell assigned Vesto Slipher, who spent his entire career at the Lowell Observatory, the job of photographing spiral nebula and figuring out what's going on. So it's Slipher who says there's something weird in this data. These are redder than I expected. And it takes Slipher and Humason and Hubble to figure out they're redshifted. They're moving away from us at tremendously high velocities. And so Hubble is the one who worked out Hubble's law. But what is Hubble's law? Well, it's the idea that virtually all galaxies in the universe are redshifted, which means they are moving away from us. There are a couple of galaxies in our local cluster, Andromeda being the main one, that are moving toward us, but everything else is moving away from us. And so when you collect the light from a galaxy and measure how much it is redshifted, that redshift is going to tell you how fast it is moving away from us, and from that we can figure out how far away it actually is. Humason got in on the project too. So in 1929, Hubble presented the first set of his, data with this distance velocity relationship that he had taken Slipher's information and done thousands upon thousands of calculations and figured out this velocity distance relationship. And so then 2 years later, they have worked together and added a lot of galaxies at much greater distances and figured out that they are moving much faster than the close ones. So Hubble's constant, if you take that velocity distance relationship, plot it, and then figure out the slope on the line right here, the slope of the line, that slope becomes Hubble's constant, and we can use that to figure out the age of the entire universe. So next week in lab, we will actually attempt to calculate the age of the universe. But until then, I will see you soon.